And I think we are moving on to the final presentation of this session. So yeah, you know the drill. Thanks.
Yeah, that's correct. Thank you. Hello again. This our work using transformer models for gender attribution in Polish, which is done by Karol Kaczmarek, me, and Filip Graliński. Okay. Next slide, please. Okay, next slide. So, what is gender attribution challenge? So this text classification task. So given a text, we want to predict whether the text was written by a male or by a female. Okay, next slide, please. Okay, next. And thank you. So we used original he said, she said data set. This huge data set, and I will talk for several minutes about this data set. So this data set is Polish internet. It's taken from common crawl, and it's a lot of text from different forums and services, and it is a data set of over 3 billion of items. So how we are able to find a gender of author? Because in English language it would be very difficult, and generally in the internet you don't have gender information associated with text. You don't know who wrote that text. In Polish language, however, it is very easy to guess, to predict gender of a person because there are gender revealing first person expression. For example, you can say "ja, I was." It can be "I was." You can translate in Polish to "ja byłam" or "ja byłam," which is different for male or female. It's similar in some other languages. For example, in Spanish, for example, I am Polish is "soy Polako" or "soy Polaka," depending on gender. So we just checked for these gender revealing first person expressions. And in this, we was able to create golden truth in this way. But if you want to make a challenge for models, we have to mask this information about the gender, because in other case it would not make any sense. So for all male text, we remained it as it was, and for all female texts, we changed these gender revealing first person expressions to male. So it was, if you read the data set, you can read something. Everything was like everything was written by a man, but you have to guess who was the original author, and you have to rely on information like topics or other features like text lengths, something like that, because it would be very unusual that a man said that I was pregnant, even if there were some man expressions in it. Okay, so next slide, please. Okay, next one. Next slide. Okay. So this allowed us to collect massive corpora. Maybe not in this work. Those done like several years before in other paper. And there are no such massive corporas in Polish or in other languages. It was possible to collect this data due to Polish grammatical rules of these expressions. Okay, so our contribution to the data set was instead of measuring accuracy, we also measured likelihood. So it's better because it's also it's measure quality and confidence of a model. And we did some data cleaning. We fixed some unwanted blank characters. Okay, next slide, please. So the model, the trained set of a model is over 3 billion items. So each huge data is a huge data set. Development and test. We have 2 development sets and 1 test set, and each of them are over 100,000 items. So it's very, very big. Okay, next one. Next slide. Okay, next slide. We also made a human baseline. The data set is balanced, so we have 50% of male labels and 50% of female. So if we use majority class, it's always accuracy of 50%. And we want to check how neural models or other baseline models perform, but we wanted also to check how it is difficult for human to guess who was the author of the text. So we created a sample of test set, def and test set. Altogether it was 1,000 items because it would be not possible for a human to go through all the test set of over 100,000 items. So it was only 1,000 items. So you can check how the humans performs. We had for humans, and it was about 65 to 67 accuracy, percent of accuracy. If we did a human ensemble by majority voting, it was 68% accuracy. So it's comparable to the method term frequency, inverted document frequency combined with logistic regression. It's almost the same, but comparing to LSTM, recurrent neural network model, it's worse. But it's still better than random guessing for humans. It's much better than random guessing. Okay, next slide, please. Okay, next slide. Next slide. Okay, so we did experiments on in 2 settings. One was constraint, so we only used training data set available in this challenge, and other was unconstrained, which allowed using pre-trained language models. In our case, we used Polish Roberta model and cross-language model trained on many languages, including Polish language. Okay, and so we trained these neural language models, this Robertas and XLM. We just fine-tune them to our task, to our classification task. But we also did another experiment. We call it fill mask. So we hide these gender attribution expressions. So there were no any expressions, and the model had to predict a word in this gap. And if the model gets for male expression, we count it as a model predict the author was male. And the other case, in the case it was female, we predict that the model said it was female. Okay, next slide, please. So here are results. So we have human baseline. Human baseline, of course, was only performed on a very sample of the data set. We have different TF-IDF approaches. We also used BLSTM, so I talked about it before. And when it comes down to Roberta and XLM models, they perform much better than other machine learning methods, better than humans. And in our experiments, Polish Roberta performed better than XLM, which is very nice. And we also did some one thing with inference, because usually when we use models with dropout, it's common to train with dropout, and during inference we disable dropout. But in the original dropout paper, they said that the most basic way to use the dropout is during inference use this dropout for several runs. For example, you have 20 runs of model with different results, and we just do averaging it. This is called Monte Carlo averaging, and it produces some result. And if you want to just run one model, we can disable dropout, and it should be more or less the same. But in our experiments, this additional experiment, when we used active dropout, we had a better result, about 1% or 1.5% better than with no dropout. Yeah, so averaging this several runs, it's slower, but it gives better results, and many people don't do that, even during some machine learning competitions when they train several models and they do ensemble of it. Now, in this approach, we only use one model and make a ensemble of it's one model, so it's much easier. Another thing is that Polish Roberta large didn't perform much better than Polish Roberta base, which can mean that Polish Roberta large is undertrained. It performs better in terms of accuracy, but worse in terms of likelihood, but the results are very similar. Okay, next slide, please. And there was another thing. This data set, which was collected like several years ago, he said, she said, it was 2020 to 2016. It used a common crawl, and Polish Roberta model also used common crawl from 2020, and some part of he said, she said training and development and test data sets was in a training data set of Polish Roberta. So we had to perform a contamination study. About 3% of he said, she said data set was included in Polish Roberta training data set, and we checked the performance of Polish Roberta model on contaminated part of data and not contaminated part of data. So we check it, for example, for Polish Roberta, for accuracy, for contaminated, the part is 77%, and for not contaminated is 74%. So for contaminated part of data sets, there's a 3% higher accuracy. So it's a significant difference, but even however, even if there is this contamination and we look only on uncontaminated part of the data, Polish Roberta performs better than other methods like LSTM. Okay, the next slide, please. Okay, in conclusion, we have another proof that transformer models are superior to other methods, and we can achieve higher result than for example, humans. And this task is very difficult. If you look at the data, it's very difficult to distinguish whether this text was written by a man or a woman. And another conclusion is that we should always do data contamination. The similar thing was done with GPT-3 model, because by accident they also fit a part of GLUE benchmark to their training data set, and they also performed. And I think in the future we will need to always look at this case, because large language models are trained on huge corpora from the internet, almost the whole internet, and it's very possible that some part of this test data set, for example, GLUE benchmark, could be included in the training data set by accident, for example. That's all. Thank you for your attention.
Thank you for the interesting presentation. Do we have any other questions?
Well, and I can also say that this data set and other data sets from my previous presentation are available publicly. So it's all available on competition platforms, so everybody can use this data set and compete.
Okay, that's cool. Yeah. Can we go back to the slides 5? The page 5, yeah. This one is actually this you try to explain the Polish, right? I don't understand Polish, but in this case, in your this data, I can see EM roughly is represent female, right? Then M is EM. And
so in
I mean, you mean female, right? You highlight in the red color is EM.
Yeah,
second also is EM.
So in Polish language,
Okay.
if the man was if the man is speaking, he would say postanowiłem with EM, and if the woman or female is speaking, she would say postanowiłam with A and AM. So
like
it's
that.
different for this very end of the word would be different for woman and man, or woman and man.
Okay.
So for example, in Spanish, you can say if man is saying is soy Polako, and woman would say soy Polaka. So it's all the same in Spanish.
Okay, because my question in your further the slides, actually, you mentioned you use n-gram, you use the 6 gram, right? You use 6 gram in your last slides. You mentioned that you use 6 gram. So in here, I don't know, because like English, the he, C, right? He, C, English is quite short the length of C. He means the male and she means female. So in your Poland here, you use 6 n-gram, right? You use 6 n-gram.
6
N-gram, okay.
n-gram.
So yeah, n-gram is
About the 6 n-grams, we just use this procedure of searching these 6 n-grams from this he said data corpus to search for in common ground to check the
Yes.
data contamination.
Yeah, you check you use 6 n-gram. Okay. So in this case, in this one here, you only one, right? Only one. I didn't say if for example is a male and female mix in this sentence. So how do you do? I mean here, right? Each sentence you only male and female. I mean in case if one sentence they have two words.
Yeah. So sometimes you can have a sentence or item with no gender revealing first person expression. So we reject this. And if there were some sentences with female and male, we gender revealing first expressions, we also rejected it.
Okay.
So if there was it was not clear from the sentence whether the author was man or woman, we just reject this sentence.
You put on the position of the. Okay. Yeah. Okay. Another one is actually in your page 12, right? 12, slide 12. Yeah. Another one, LSTM. I mentioned you mentioned LSTM in the initially LSTM can reach the accuracy around 73. Compared to
the model, yeah.
Yeah, compared to the TF-IDF is also only 68.
Yes, can you go to slide? I think it was 15 or.
Yeah.
Slide 15 or.
Maybe you can go to slide 12. 1, 2. Yeah.
Can you go to 12?
12, 1, 2. Yeah.
Yeah, 1, 2 slide.
Yeah.
Okay.
Yeah, here actually in the beginning, your LSTM you can reach around 73, but after this one, I saw the.
Yeah. So your question is that there is a different.
Yes. Here actually LSTM dropped down a lot. So.
Yeah, because here there is an inference on whole data set of over hundreds of thousands of items in development and on test data set. And before, when we made the comparison with human baseline, we evaluated this LSTM only on this very sample of 1,000 items, on which also humans were tested.
Okay. Yeah, because interesting, I found your last a few slides is quite interesting. You thinking because you are using the same data size for the pre-trained the model, and you also in the real test model, so you think it's maybe contaminated. Because usually we split this one, right? Just like before, you mentioned you split it as a A2, or maybe you use cross-validation, just split the different faults, then try that one. So yeah. So interesting, gender. Yeah. Okay. Okay, cool. Yeah, thank you.
Thank you very much.
Thank you. Do we have other questions? Okay, so it's the usual suspects. Then I have one or two more questions. So maybe you can a bit provide the motivation about this research and what's the applications. I have a few in mind, but maybe you can say what was your original idea. How, if this system works perfectly, how would you use this in production?
Okay, so it's not very clear how we can use it, but for example, it can be useful in psycholinguistic studies, because there are some linguists study that show that there are different topics which about which women and men talk in the internet or generally. For example, men generally speaks about, for example, you can speak about vehicles like cars and football and sport, and women rather more about pregnancy, for example, or for example a partnership. At least it holds also true when we check on this data set. For example, at least people who are using these pronouns. And we believe that this data set and these models can in some way improve our knowledge and can help linguists in their research. There are also not only difference in topics, but in grammatical structures. For example, men usually use shorter phrases and are more direct than women, and don't, for example, use emoticons.
Yeah, okay, thanks. And then I have a few more ideas. One of them is maybe you can use that in chatbot or customer support, maybe something like that. That's one idea. And I have one more, again, idea. I don't know if it would work, but do you know how is the gender distribution in your data set, in your training data set now?
So in this data set, it's 50% for female and 50% for male. It's our data set because it was especially balanced for this challenge, but how it was before, I don't remember. Okay. And that's true that it can be used for chatbots. Thank you. But there are a lot of gender bias topics lately in the conferences. So maybe it can be useful. This paper can be useful in these topics.
Okay, and then about the data sets. So maybe my assumption is that you use some rule-based to approach, to classify those sentences before you do the cleaning.
Yeah, that's true. It's rule-based.
You can flip the phrases. If the sentence is written by a male, you can flip it and turn it into a sentence written by a female, and flip the whole data set, and then use it as a test data set and see what you get, or try some combination of this about validating the approach. This again, some idea. I don't know what.
Yeah, it's a very interesting idea. If we can flip because now every expressions are male, and would everything be different if that was female? It's an interesting question. If the transformer models would perform the same or not.
Okay, thank you.
Thank you. Thank you very much.